So on page 211, we're just going to go over a few practice examples of how we can find the derivative of these implicit equations. So these are just for practice, getting used to the technique. Every time we take the derivative of a y variable, we need to write that dy over dx derivative symbol. Now, just to make sure this is quick and to the point, we're going to go ahead and do the first two together. And I would like you to try the bottom two just to see how far you can get, but we'll pick up in class tomorrow with the rest of the two at the bottom. So taking a look at the first one, we're going to find the derivative of 2y, or sorry, not 2y, y squared, and if you were to use the power rule shortcut, we would simply get 2y as a derivative. But since we took the derivative of a y variable, we immediately have to write in that dy over dx. If we continue on the right-hand side, the derivative of 2x is simply 2. And then we'll add the derivative of 3y, which would be 3. But since we took the derivative of a y variable, we have to write dy over dx. So this one's a little different than the previous ones we were looking at, because notice how we have two of those derivative symbols showing up. And our goal is to eventually solve for dy over dx. Like, for instance, we want to get dy over dx equal to something. Okay, we want to figure out what that something is. So we have some algebra to go forth from here to help us get to this point. Now, since we're trying to solve for dy over dx, I recommend getting all of these derivative symbols on one side of the equation, and everything else that does not have this derivative symbol in it, move it to the other side of the equation. So for instance, I'll go ahead and subtract this 3 dy over dx to the other side so that I have both derivatives next to each other. All right, so something like that. Now, here's the magic step. Notice how both of these terms have a dy over dx in common. So that means we can factor out that dy over dx as a GCF, okay, the greatest common factor. So that's the math magic of this process, where we can go from multiple dy over dx's to one. Okay, we're going to use factoring to help us with that. So if we pull a dy over dx out of both of those terms, we're left with a 2y minus 3. And in order to get dy over dx all by itself, we can simply divide this 2y minus 3 to the other side. All right, so there is our implicit derivative. Let's go ahead and try the next one. So we're going to work our way across just like we normally would find derivatives, but every time we take the derivative of a y variable, we must write dy over dx. So the derivative of 2x is just 2, and then we'll add the derivative of e to the y. Now, the derivative of e to a power is simply e to the power times the derivative of the power. So the derivative of y would just be 1, and since we took the derivative of a y variable, we need a dy over dx. Moving on to the next side, derivative of x squared is 2x. And the derivative of y squared would be 2y. Again, we took the derivative of a y variable, so we're going to write dy over dx. So it looks like for this example we have multiple derivative symbols showing up again. We're going to go ahead and get those derivative symbols on one side of the equation, and everything else that does not have a derivative symbol, for instance, this 2 and 2x, will move to the other side. So it doesn't matter which side you move where, or what terms you move where, as long as you're consistent. I'm kind of more in tune to moving the derivatives to the left-hand side, just because that's what we're solving for, but it's completely up to you. So on the left side, I'll have e to the y dy over dx. And if I wanted to move this derivative term to the other side, I'd have to add it over. So 2y dy over dx. On the other side, I'm not going to move the 2x, but I will subtract this 2 over. So I'm just doing a little rearrangement of terms here. And now that the derivatives are on the left-hand side, we can factor out that dy over dx notation, since it's a GCF. And again, that's kind of the magic step, because we go from having 2 derivative notations down to 1. And now that we just have 1, we can solve for it by dividing e to the y plus 2y to the other side. So 2x minus 2 over e to the y plus 2y. All right, so there's our derivative for this implicit equation. Again, go ahead and try the bottom two, see how you fare, and we'll go ahead and check those out tomorrow.